Hey guys, so in this video I'm going to discuss about the feature selection, filter based feature selection with the help of ANOVA correlation coefficient. So we use ANOVA correlation coefficient when we have numerical input and we have a categorical data as output. So we have numerical input and categorical data as output, so we can assume that we can use ANOVA. So and of course the relation should be linear, relation will be linear. So here again I'll come here to spider, and so this is the same code which we used in previous videos as well. The only change I did in this part of code, I added this part of code, and what I did is, so uh, if you can just see that we had these 20 variables and we took it in x and y. I've already explained how we took it and why we use 0 to 19 in my previous videos. So the only change I did was adding this code, and this code, what it does is, it first of all takes this function again, select k best, which we used when we were calculating the Pearson correlation coefficient as well. So this one, in this also Pearson correlation coefficient also we used select k best function only, which we have imported here in this line from sklearn to feature or dot feature selection import select k best. And for ANOVA we need to use this function from sklearn dot feature selection import f underscore class f. So this is what we use for ANOVA. So again, for ANOVA is equal to select k best score function, we give this f underscore class f, which indicates that we want to use ANOVA. Then we want to have the first two best two features, so we keep k is equal to 2. Then we have uh, then here we are trying to fit x and y. So what we do, we use this variable which had this select k best function, which could call this. So we use this for ANOVA dot fit, and we fit x and y. X is the features and y is the target variable. X are all features. Then we have fitted model here, this variable. Then we just check the scores here. Print x cell for ANOVA fit dot scores, right? So we have the scores here, and then what we do, we transform our x variable based on this fit, which we did in this step, right? We try to transform our x variables, x number of features, x basically x represent the number of all features here. So it has all the features, all the columns which represent features here. So we try to transform it based on our this fit, which was based on this function select k best. So when we transform it, it selects the best two features and put it in x cell for ANOVA, this variable. The best two features which were selected based on ANOVA test are being extracted in this step, and they are being stored in this variable. Now we print this variable, that what data is there in this variable, and now we check. Now let's check, let's run it again and let us check. So let us check here. So when we print scores, if you see, we have all these scores for different features. So basically what these scores represent, that what is the relation of that particular feature with our target variable. So if you notice, the last two variables are having the highest score, and that is why when we do this transform step, and then when we print this variable which has the selected features, it will have always the last two columns because they had the highest scores here. See that, check here. So if we go here, so our df had all the data. So if you go here and if you check, then you see these are the variables. Audit risk was our target variable. So these two variables, see 18, 19, 18, 20. So these are the variables which are the basically are being selected, and they were selected because they had the highest scores here, right? I just matched the how did I know that these were the last variables? That might be the question from you. So I just matched the value, the T19 E20 here, just for the sake of it, just for showing you. So 18, 19, 18, 20. See, this is the same. Sorry, yeah, this one 18, 19, 18, 20, 38, 41. So we can directly see, okay, this is the last two variables here as well. Otherwise also we can print it. So here it's very it's pretty simple. We can match it and we can see that yes, they are the two last features in this data set, and they were selected because see 18, 18, 38, 18, 18, 38, 19, 20, 40, 94, right? The last one also we can match, yes, 6877, 6390. See, so why these two last features were selected? Because these were having the highest scores when being fit based on ANOVA, when the features were fitted on the basis of ANOVA function here. So I hope I'm clear about this. It's a very small code and can be easily used in any Python machine learning program for feature selection. So thank you for now, and yeah, in the next video I'll discuss more about, basically I'll discuss about other feature selection methods as well. So as of now, thank you.